This is a demo showing how to programmatically refresh a Power BI dataset, table, or petition. Traditionally, when you want to refresh a Power BI dataset, you can either do it manually in the portal or set up a refresh schedule within Power BI service. But this is not granular enough. It doesn't give you the control over which table or petition you can refresh, and that can be problematic for very, very large data sets. Alternatively, you could also use a tool such as Tabular Editor or SSMS and go to specific petitions and then kick off the refresh from there. But this is a manual process and it's not automated, thus it's not scalable. With the introduction of XMLA endpoint within Power BI, you can actually set up the programmatic refresh of Power BI dataset tables and petitions. First, we're going to go over the high-level architecture for the programmatic refresh. In order to run the XMLA scripts against Power BI service, we need PowerShell to be hosted in either something like Azure Automation Runbook, or you could use something like functions. Essentially, it will use a service principal authenticate against Power BI service and then kick off the refresh using a specific XMLA script. Of course, you want to keep your Power BI service principal safe, so you want to provision something like a key vault to keep your service principal there and give automation managed identity access to the key vault to get the secret for Power BI service principal. And also, you don't want to hard code your XMLA script within Automation Runbook. So you want to use something like Data Factory to orchestrate your runbook and pass in the XMLA script or potentially the target workspace, and maybe you can set up dependencies, you can set up schedules and use Data Factory to manage the entire run. And to keep the entire thing safe, you could use webhook URI within the automation runbook and keep that within Key Vault as well. So you will need to give the Data Factory Managed Identity access to Key Vault to list that secret so you can get the runbook URI and then kick off the runbook by giving it the specific XMLA script to run. Then runbook will go to Key Vault and get the secret it needs to authenticate against Power BI and then run those scripts within Power BI. And Power BI will give the results back to Data Factory as well as and how we set it up. Now let's take a look at the whole thing in action. So first thing we have is a automation account, and within automation account we set up a runbook that housed a PowerShell script. So it's expecting the webhook data as parameters, then has a series of parameters, and you can see that we are basically passing in the XMLA query or script from Data Factory. We're also passing in the target workspace name from Data Factory as well. This is standard for the Power BI XMLA endpoint URL. and your workspace name will be at the end of this URL. And then this sets up the connection between automation account and key vault. It's telling automation to go to this specific key vault, get this specific secret, and we have stored the application ID, the secret value, and the tenant ID of our Power BI in the key vault. Then it will construct the credentials and then pass it to Power BI in order to authenticate and run the script itself. With this, it will try and run the body, which is what we pass in as XMLA script. If it's successful, it will send back a 200 status to Data Factory. If it's not, then it will send a 400 to Data Factory. So once this runbook is published, we have created a webhook as well. For this webhook, all we needed to do is to save the URI and then put it in our key vault. And so within our key vault, we have given our Data Factory access to list the secrets, so it can get that webhook URI and kick off the runbook from Data Factory. And also we've given the automation account access to list the secrets as well, so it can get the Power BI service principals and the tenant ID for our Power BI. So going to Data Factory now. Within Data Factory, we have a base refresh pipeline. The activities are quite simple. The first one is a web activity. All it has is the URL of our secret, and this is the secret of the webhook URI. So this is just getting that webhook URI back to Data Factory, and this is a standard setup for Data Factory to talk to Key Vault and get certain secret back, because we have set up access policy in Key Vault so that Data Factory's managed identity can list and get secrets. It will be able to get the secret back from Key Vault. The second activity is the webhook activity. So the URL is what the activity of previous activities output as the value. So we get that webhook UI back from Key Vault, and we use it here as the URL, and then we kick off the body, and this is what we actually pass to the runbook as the XMLA query. As you can see, we're passing the workspace name and the XMLA script. In this case, both of these are saved as the pipeline parameters. So we had the default value in here. If I copy out the default value, you can see that what this is doing is, if at runtime I don't pass in a parameter, it will refresh the data set that called Adventure Works and a table called Customer. If I do pass in a value at runtime, and then it will use the value that I pass in instead. And again, for the target workspace, you can see that I have the default value as test, and this is what the data factory will pass to the automation runbook if I don't give it a specific value at runtime. Now let's debug it. We'll leave everything as default and it will run. We'll see that it kicks off. The first thing it will do is to go to key vault and try to get that webhook UI back, and then it will use that webhook UI, talk to the automation runbook, pass in the default pipeline parameters we have set, and that should kick off the refresh of the customer table within the Adventure Works dataset. So if we go to Power BI service for a moment, this is our test workspace and the Adventure Works dataset. If we go to settings and look at refresh history, you can see there's one that's just done using XMLA endpoint, and this is the one that we kicked off. And that is how it's done on a base level. But because we said before that you could use Data Factory to actually do orchestration, the next piece we're going to show is how that orchestration can be done. So within Data Factory, you can actually call another pipeline to run. So here we have 3 activities chained. Each of them is execute pipeline. All of these we are calling the previous pipeline that we had used as the base pipeline. And here we are passing in different values for the different pipeline runs. For this one, we are getting the table customer refreshed. As you can see, this one is refreshing the table customer. The next one, after the successful running of this one, will run a different refresh script, and that one is refreshing a particular table's particular partition. At the same time, it's refreshing a different table. So you can have several of these in parallel. They don't have to be at the same granularity. You can pass in tables and partitions in the same script. And you can also pass in multiple tables or multiple partitions in the same script as well. And after this refresh is done, the next one we're going to do, again, is utilizing the same exact underlying base pipeline, but we're just passing in different parameters for the pipeline. The last one we're going to run is a big dimension table. So for here, we are not specifying the partitions, but we're telling the script to run the maximum parallelism of 10, and you can set this parallelism yourself, and Power BI does have a limit based on your capacity for the maximum parallelism it will actually run, but you can set it yourself to be higher or lower as long as it doesn't exceed that maximum limit, and it will try to give you as much parallelism as possible if you do set a very high number that exceeds your capacity limit itself. But the idea is, if you have a very big table, then you can set maximum parallelism to try to increase the parallelism so that the refresh is done faster. So with a chained pipeline like this, you can actually set up orchestration for your entire data set within different tables or potentially different data sets if they have any kind of dependencies whatsoever.